Welcome to your Additive Manufacturing News Review. Every 2 weeks, we bring you the latest breakthroughs, industry shifts, and cutting-edge innovations shaping the future of 3D printing. Today is Saturday, the 15th of March, 2025. Let's dive in. Another report by OpenPR states the global 3D printing metal powder market is projected to expand rapidly, with forecasts predicting it will grow from $621 million in 2024 to $1.67 billion by 2028-2030. This represents a staggering 17.9% compound annual growth rate, fueled by rising demand in aerospace, medical implants, and automotive engineering. The challenge, however, lies in scaling up production while controlling material costs. As the demand for metal additive manufacturing increases, software solutions are also evolving. The AM software market is expected to reach $6.7 billion by 2033, integrating AI-driven workflow automation and process optimization to enhance efficiency. Software is no longer just a design tool. It has become the backbone of scalable, data-driven AM ecosystems, ensuring precision and reproducibility at an industrial level. Meanwhile, in India, additive manufacturing is gaining momentum at an impressive pace. The country's 3D printing sector is projected to grow from $61.4 million in 2023 to $314 million by 2030. Making it one of the fastest-growing AM markets in the world. Government initiatives are playing a key role in this expansion, with policies supporting 100 new startups and 50 cutting-edge AM technologies, positioning India as a hub for cost-effective, scalable 3D printing solutions. As we move beyond the numbers, it's clear that materials and software alone aren't the only driving forces in AM innovation. The introduction of advanced metal powders, AI-powered design automation, and digital twins is transforming how manufacturers approach production. Let's take a closer look at these breakthroughs. One of the most significant developments comes from EOS, which has introduced two new nickel-based alloys for oil and gas, semiconductor, and chemical industries. The first, EOS Nickel Alloy Inconel 718 API meets API 6 ACRA standards, making it a prime choice for high-stress applications such as downhole drilling and injection components. The second, EOS Nickel NiCP, eliminates the need for electroless nickel plating, extending the lifespan of corrosion-resistant parts in demanding environments. But materials are just one part of the equation. AI-driven design automation and digital twin technology are changing how engineers create and optimize parts. Backflip AI has developed a groundbreaking AI model that automatically converts 3D scans into digital twins, making it possible to generate 3D printable replacement parts in minutes instead of days. This advancement has the potential to cut downtime by up to 50%. An invaluable benefit for manufacturers who rely on continuous production. AI isn't just transforming scanning and replication, it's revolutionizing 3D design itself. Companies like Zoo, NVIDIA, and Markforged are making text-to-CAD software more accessible, allowing engineers to generate optimized 3D models from simple text prompts. Instead of manually building a model in CAD software, an engineer can describe a component's function and constraints, and AI will generate an optimized, ready-to-print design. These advances in materials and AI are enabling manufacturers to create stronger, lighter, and more complex metal parts than ever before. But where are these innovations being put to the test? The answer lies in aerospace and defense, where AM is redefining what's possible. One of the most groundbreaking achievements comes from GE Aerospace, which has received FAA certification for its 3D printed catalyst engine. This engine, designed for next-generation aircraft, replaces 855 individual parts with just 12 complex 3D printed components, reducing weight, enhancing fuel efficiency by 18%, and improving cruising speed by 10%. The success of the catalyst engine signals a new era of 3D printed propulsion systems that are lighter, more efficient, and easier to manufacture. Meanwhile, on the defence front, America Makes and the UK Ministry of Defence are collaborating on a $1.1 million initiative to standardise laser powder bed fusion (LPBF) processes across US and UK defence supply chains. This project aims to establish interoperability standards for critical AM components, ensuring that both nations can seamlessly integrate additively manufactured parts into their defence infrastructure. The naval sector is also embracing AM, with HII successfully installing the first ever 3D printed valve manifold on an aircraft carrier. This 1,000-pound component, produced using advanced AM techniques, not only reduced manufacturing lead time, but also improved efficiency in naval shipbuilding. With aerospace and defense proving the reliability and scalability of metal additive manufacturing, industrial players are now looking at ways to bring AM into full-scale production. This shift requires massive investment and a commitment to digital transformation. Bringing additive manufacturing to industrial scale isn't just about technology. It's about infrastructure, investment, and a commitment to digital transformation. Leading companies are making billion-dollar bets on the future of AM, and they're doing it now. Siemens is investing over $10 billion in US manufacturing, AI-driven automation, and industrial AM expansion. New electrical product facilities in Texas and California are being built to support the rise of AI-powered factories and AM production hubs. These investments will help accelerate the adoption of smart manufacturing, where AI, real-time monitoring, and AM work seamlessly together. To ensure industrial-scale AM adoption, Siemens is also pushing for a fully integrated digital thread strategy. This approach links 3D printing, AI, and automation into a single, traceable production pipeline, allowing manufacturers to track quality, predict maintenance needs, and optimize production efficiency in real time. As AM technology advances, investments grow, and production scales up, one thing is certain: metal additive manufacturing is no longer a niche technology. It is the backbone of modern industrial production. As metal additive manufacturing accelerates across industries, one thing is clear: AI, automation, and digitalization will be the defining forces of the next decade. From certified aerospace engines to real-time digital twins and billion-dollar investments, AM is no longer just the future. It's the present. And that's a wrap on this week's biggest stories in additive manufacturing. Stay tuned for more updates and keep innovating.